Leonardo da Vinci, the renowned Renaissance artist and inventor, was fascinated by the concept of flight. His notebooks contain numerous sketches and designs for flying machines. One of his most famous designs is the ornithopter. This device was intended to mimic the flapping wings of birds. Though it was never built, the ornithopter showed Da Vinci's deep understanding of aerodynamics. Leonardo also sketched designs for a helicopter-like machine. He called it the aerial screw. This device consisted of a spiral rotor that, when turned, would lift the machine off the ground. While Da Vinci's designs were never realized during his lifetime, they were remarkably ahead of their time.
In addition to mechanical designs, I studied the flight of birds. I observed how birds use their wings to create lift and control their movements. These observations informed my designs and contributed to my understanding of flight dynamics.
George Cayley, an English engineer, is often called the father of aerodynamics. In the early 19th century, he made significant contributions to the understanding of flight. Cayley identified the four fundamental forces of flight: lift, drag, thrust, and weight. His work laid the scientific foundation for modern aeronautics.
I built the first successful gliders capable of carrying a human. I tested these gliders by launching them from hills and observing their flight. One of my most significant achievements was the development of a fixed-wing aircraft. Unlike earlier designs that relied on flapping wings, my glider had a rigid wing structure. In 1804, Cayley built a model glider that demonstrated the principles of flight. He continued to refine his designs, and by 1853 he had built a full-size glider.
Otto Lilienthal, a German aviation pioneer, is often referred to as the glider king. In the late 19th century, Lilienthal conducted extensive experiments with gliders. He built and flew several types of gliders, making over 2,000 successful flights. Lilienthal's work provided valuable data on the behavior of aircraft in flight.
My gliders were designed based on careful observations of bird flight. I meticulously documented my experiments, noting how different wing shapes affected performance. My approach was scientific and methodical, contributing significantly to the understanding of aerodynamics. One of Lilienthal's key contributions was his emphasis on stability and control. He recognized the importance of a stable aircraft design. Lilienthal's gliders featured wings with a dihedral angle, which improved stability during flight. Tragically, Lilienthal's pioneering work came to an end in 1896 when he died in a glider crash. Despite this, his legacy lived on.
Section 5. The Wright brothers, pioneers of powered flight. Orville and Wilbur Wright, two American brothers, are credited with inventing and building the first successful powered airplane. Their breakthrough came on December 17, 1903, when they made their historic flight at Kitty Hawk, North Carolina.
The Wright Flyer, our aircraft, stayed aloft for 12 seconds and covered 120 feet. Our success was the result of years of experimentation and innovation. They built on the work of earlier pioneers like George Cayley and Otto Lilienthal. However, they introduced several key innovations. One of the most important was their development of three-axis control. This allowed the pilot to steer the aircraft effectively and maintain stability. Another significant innovation was our use of a wind tunnel. We built a small wind tunnel to test different wing shapes. This allowed us to gather precise data and optimize our designs. The Wright Flyer was powered by a custom-built engine and featured a lightweight yet strong frame. After their initial success, the Wright brothers continued to improve their designs.
Section 6. Aviation in World War I, a catalyst for innovation. World War I was a significant period for aviation. The war accelerated technological advancements and demonstrated the strategic importance of aircraft. Initially used for reconnaissance, airplanes soon engaged in combat and bombing missions. Warfare demands drove rapid innovation, leading to powerful engines and synchronized machine guns. These guns could fire through the propeller, transforming aircraft into combat machines. Fighter planes like the Fokker Doctor I and Sopwith Camel marked a new era in aerial warfare. The lessons from World War I profoundly impacted aviation. The Golden Age of Aviation. Between World War I and World War II, aviation saw significant advancements. Numerous record-breaking flights marked this era. Charles Lindbergh's solo transatlantic flight in 1927 was a notable achievement. He flew from New York to Paris, capturing the public's imagination. Amelia Earhart became the first woman to fly solo across the Atlantic in 1932. Her adventurous spirit made her an iconic figure in aviation history. The era also saw significant advancements in aircraft technology. Section 8. The rise of commercial flights. The rise of commercial aviation began in earnest after World War II. The war had driven significant advancements in aircraft technology and infrastructure. These advancements were quickly adapted for civilian use, leading to the growth of the commercial aviation industry. One of the key developments was the introduction of jet engines. The de Havilland Comet, introduced in 1952, was the world's first commercial jet airliner. It offered faster and more comfortable travel compared to propeller-driven aircraft. The Boeing 707, introduced in 1958, further revolutionized air travel with its long range and large passenger capacity. The post-war period also saw the establishment of major airlines and the expansion of international air travel. Airlines like Pan Am, British Airways and Air France became household names. They connected cities across the globe, making air travel accessible to a broader segment of the population. The Boeing 747, introduced in 1970, became known as the Queen of the Skies. The rise of commercial flights transformed the way people traveled. Section 9. Modern aviation technology. Modern aviation technology has advanced significantly since the early days of flight. Today's aircraft are marvels of engineering, featuring sophisticated systems and materials. Advances in avionics, aerodynamics and propulsion have made air travel safer, faster and more efficient.
One of the key advancements in modern aviation is the use of composite materials. These materials are lighter and stronger than traditional metals. Aircraft like the Boeing 787 Dreamliner and the Airbus A350 use composite materials extensively, improving fuel efficiency and reducing emissions. Avionics systems have also seen significant improvements. Modern aircraft are equipped with advanced navigation, communication, and flight control systems. These systems enhance safety and reliability, allowing for more precise and efficient operations. Innovations like fly-by-wire technology have replaced traditional mechanical controls with electronic systems. Another area of advancement is propulsion. Modern jet engines are more powerful and fuel-efficient than ever before.
Section 10. The future of aviation, UAVs and space travel. The future of aviation holds exciting possibilities with advancements in unmanned aerial vehicles or UAVs and space travel. UAVs, commonly known as drones, have seen rapid development in recent years. They are used in various applications, from military operations to commercial deliveries and aerial photography.
Drones offer several advantages, including the ability to operate in environments that are difficult or dangerous for manned aircraft. They are also more cost-effective and can be deployed quickly. Ongoing research is focused on improving drone technology, including longer flight times, greater payload capacities, and enhanced autonomy. Space travel is another frontier in the future of aviation. Companies like SpaceX, Blue Origin, and Boeing are developing technologies for commercial space travel. Space tourism is becoming a reality, with private companies offering suborbital flights for civilians. These developments are paving the way for a new era of exploration and travel beyond Earth's atmosphere. In addition to tourism, space travel has significant implications for research and industry. The future of aviation is marked by innovation and exploration.